Welcome to today's webcast, brought to you by Qlik, SentryOne, and DataKitchen. I'm Stephen Faig, Director of Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled, Unlocking the Power of DataOps. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, all viewers today will be entered to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, Dan Potter, Vice President of Product Marketing at Qlik, Douglas McDowell, Chief Strategy Officer at SentryOne, and Chris Bergh, CEO and Head Chef at DataKitchen. Now I'm going to pass the event over to Dan.
Hey, thanks, Stephen, and welcome, everyone. I'm going to be talking about DataOps and how it applies to providing more agile analytics with the goal of helping really to accelerate time to insights to make better, faster decisions. And in this current economic climate, nothing's probably more important than that. You might know of Qlik as an analytics company, which makes sense. You might not know about Qlik as a data integration firm. This came about last year, almost exactly a year ago, when Qlik acquired a company called Attunity for over $500 million and combined it with a previous acquisition, really to build a best-of-breed data integration platform, leveraging some unique capabilities that fit perfectly with the notion of DataOps, meaning real-time data movement, movement to the cloud, and helping organizations become more agile and automating pipelines and making it available to business users. So that's kind of where we come from. But if you step back and talk about, where does DataOps come from? Really, its roots are around DevOps and the notion of DevOps and helping what DevOps did to software development in accelerating time to value and helping move away from long waterfall cycles to much more agile and effectively moving to continuous development, integration, testing, and deployment. So that whole notion of DevOps really helped shape the thinking around DataOps and how do we take that same kind of approach and help to accelerate the time to insight. How do we deliver the right data faster to the data consumer, make that data more real-time, and help with the resilience? So when things change on the source side, how do we deliver continuously to users? Traditionally, it's been a waterfall-like cycle for data delivery. If I want to add more data to the warehouse, someone needs to design it. I've got a team of people that code it. It moves into test. It moves into deployment. And these can be 6 to 9 month cycles. The orientation has traditionally been batch process. Again, these teams of people are doing brittle ETL scripting. And by the time it gets delivered to the business user, it's already outdated. So what's needed is a different approach. And this is where the notion of DataOps really comes into play, removing those long cycles, automating so you can deliver faster to the business user, deliver analytics-ready data. It's continuously updated. It's completely resilient. As they need more information, we're doing this in hours and days, not months. So the notion of DataOps is important, but you can't buy DataOps. What DataOps is, it's around accelerating how people are organized, the process and to get you there, the technology to help. And this is where I'll spend a few moments talking about how enabling technology and emerging technologies can significantly help. But make no mistake, you don't go out and buy DataOps, just like you don't buy DevOps. It's something you do. It's not something that you buy. Having said that, let's talk about some of the key enabling technologies. Well, first, from an analytics perspective, people are looking to take advantage of advancements like AI and machine learning, sensor data and IoT, predictive and preventative analytics, more real-time analytics. To do that, it's really heralded a new set of platforms to do that. It started with big data, Hadoop, moving more now to cloud and cloud data lakes, to cloud data warehouses like Snowflake, to real-time streaming like Kafka. So there's a whole emerging set of platforms and technologies to help support modern analytics. Well, what's really needed as you move to these new platforms is a modern style of integration, and that's what's going to get you from a technology perspective to be able to really achieve a data ops approach together with the people and process side. So what I want to do is share kind of the 5 key technology requirements as we see it at Qlik. And the first one being continuous integration, right? Much like DevOps is all around continuous integration delivery, same thing with data ops. How do I stream changes to data, the source data system, in real time? And this is where change data capture becomes critical. Change data capture is a unique technology that enables you to be able to detect changes in a non-invasive way, changes to both the source data and the metadata, and to push those changes out to where it's needed. Done right, and we think that the log-based way is the right way to do it. It's the optimal way because you have minimal impact on those core source systems. And when you're talking about source systems like mainframe and SAP and large Oracle servers, it becomes absolutely essential. And that brings about the second requirement, which is a solution needs to be universal. You have lots of different sources. You have lots of different targets. Both the source and targets are continually changing, especially on the target side. If you look at the number of new technologies and new targets on the cloud, that's ever changing, and that's a good thing. You want to be able to take advantage of those new technologies. So you want a solution and you want to build pipelines that enable you to move data in real time, to deliver it where it's needed, and to be able to create analytics-ready data sets regardless of that endpoint. That endpoint may be traditional database replication like an operational data store. It may be into a new cloud data warehouse like a Redshift or an Azure SQL DW Synapse or a Snowflake. It may be into a data lake in Azure or Google or others. So you want to be able to build dynamic pipelines. You want the agility to move it to where it's needed, but to do it right, you really need to automate it. And this is where you move away from those traditional ETL hand scripting, and this is where a lot of the value comes from, the automation. It's not easy because as you're moving to things like data lakes, this is multi-stage processing. You need to be able to adapt to source and target changes. You're dealing with heterogeneous and highly distributed workloads. When you think about like a data lake, I'll give you an example. In the context of a data lake, to do this right, you're capturing changes through change data capture. You're optimizing the delivery of that into the cloud. So you've got partitioning strategies. You've got continuously changing data. So I'm delivering those raw Delta files all of the time. I need to be able to take those updates. I need to be able to merge and stitch that information together. I need to create a full change history so then I can deliver analytics-ready and purpose-built subsets of that data for analysis. And the analysis may take different shapes. It may be a historic data set for a data scientist. It may be a snapshot for someone doing analytics or an operational data store that needs real-time updates. So you need to be able to automate to different use cases. And finally, if you look at what's happening in the world of data architectures, the data warehouse and the data lake, they're really starting to blend and to merge. You're seeing some really interesting approaches like Microsoft, blend the line between what is a data lake and what is a data warehouse. Same thing with many of the other vendors as well. You may have traditional enterprise data warehouses on-prem. You may have a data lake and data warehouse strategy where the data lake may feed into the data warehouse. You may think of your data lake as the be-all and end-all source. So when you go to capture those changes, deliver that data, optimize it to the different targets, you may have one deployment methodology. You may have multiple. I can assure you that it's going to continuously evolve. So the fourth requirement is agility. Agility is really important because you've got, again, a data architecture that's continuously evolving. You've got data sources that may be on-prem, maybe in the cloud, maybe multi-cloud. More and more, you're going to be delivering data and drawing from data across multiple clouds. You want to be able to take advantage of emerging technologies and data lakes, data warehouses, cloud data warehouses. So you want to deliver that data, and you want to automate the creation of analytics-ready data sets within things like a Snowflake or a cloud data warehouse. The whole notion here is setting yourself up to be future-proof. As there are so many things in motion, cloud technologies, emerging technologies, things like Databricks, Confluent, and others. There's some great options now that really deliver business value, but only if you have the agility to be able to take advantage of that. So you need to be thinking about, how do I future-proof myself and build an agile data infrastructure and have a data integration approach that's going to allow me to take advantage of these next generation advances. The final step here is trust, and this is probably the most important thing to consider. As you build out all these great data repositories, you're moving it in real time, and you're making it available to the business user. It's only valuable if the business user can find it and can trust it. And that trust comes by understanding. They need to make sure that one, they understand where the data came from, how it was transformed, who else is using this data. So having strong lineage is really important. And having a catalog that exposes that data lineage, that makes it available. So when they find the data set that they need, they can understand that data lineage. But it also becomes critical to make sure that once I find that data, I'm comfortable with that data. Now I want to be able to provision that data directly into whatever analytic tool I like. So it may be Qlik, which is an awesome analytics tool. It may be Tableau. It may be Power BI. It doesn't matter to us. Our approach is, again, to be independent and agnostic. We don't care where the data resides, how it was transformed, and how you want to consume that data. We'll provision it directly into your analytic tool of choice. And this delivers great value to the business user. Right? So they can find the data, they can immediately bring it into an analytics tool. And if you're using an advanced analytic tool like Qlik, you've got the power of AI and ML, the augmented intelligence approach, where I can bring it directly into insights that are machine generated. So this is how you go from kind of raw data to real-time insights and taking a data ops approach to help get you there. So those are some considerations. I hope this has been helpful. There's a lot of great information on the Qlik website. You'll find reports from Gartner and Eckerson around data ops, which should really help you gain a better understanding of some of the considerations and how best to get there. Stephen, back to you.
Why don't we proceed with our next speaker today, Douglas McDowell, Chief Strategy Officer at SentryOne.
Excellent. Thanks so much, Stephen. I want to talk for a few moments about intelligent data ops, and I really appreciated the slides that Dan just went through, and you'll find a lot of synergy between the things that we talk about. And SentryOne, if you don't know, we focus on database performance monitoring and data ops tools for the Microsoft Data Professional. We're focused on improving the quality of life for that Microsoft Data Professional and their customers. I want to start off talking a little bit about the term data ops because it is still new to a lot of folks. And if you go to a source like Gartner, this is back in 2018, I think Nick Hudecker did a good job in his blog talking about what data ops is. It's a collaborative data management practice that's focused on improving communication, integration, and automation of data flows between data managers and consumers across an organization. The goal of data ops is to create predictable delivery and change management of data, data models, and related artifacts. Data ops uses technology to automate data delivery with appropriate levels of security, quality, and metadata to improve the use and value of data in a dynamic environment. It's a lot packed into there. And I love all of that, and we'll talk about some of it. The one thing that I always like to add when I talk about data ops is that performance isn't called out here. And performance tends to be a central tenet of data ops, because anytime that you have any interaction with data, you need to trust it, you need to make sure it's secure, but then it's all about the performance of it, whether you're getting a report, interacting with a data-centric application, whether you're doing analytics. The report card always tends to be about how well it's performing, how quickly you can interact with it, get the answers that you need, and then move on. And so I always call that out. I want to call out specific words in here that data ops is a practice. Dan talked about this, that you don't just buy data ops, you do data ops. So it's a practice, and it involves communication, integration, and automation. Data managers and consumers are the people that are involved there, and it leverages technology. And so I think about the metaphor of the three-legged stool. Any leg that's missing, it falls over. So when you're supporting data, data assets, data-centric application, it involves the people, the processes, and the technology. And so I started off by saying, I'm going to talk to you today about intelligent data ops. And so you asked the question, I understand data ops. What's intelligent data ops? Well, intelligent data ops, a simple way to think about it is analytics for data ops. A use case for data ops, one of the prevalent ones, is around analytics. And so there can be data ops for analytics, but this is analytics for data ops, making sure that your data ops, the people, the processes, and the technology uses a degree that you make them smart, you inject intelligence into them. And to use the analytics continuum that Gartner references regularly, you've probably seen this many times. How do we move from hindsight to foresight, and move along from descriptive analytics, diagnostic, predictive, and prescriptive? That's all about your journey in data ops and what you're doing to create more value. Of course, more difficulty comes with it as you want to progress from just being informed about something to predicting what will happen or affecting what will happen. And so let's talk about that in more detail. The best way to talk about that is I want to talk about some of the things that SentryOne did. We don't just make data-centric software. We're also a data company like any others. And so we had to embrace data ops, and we had to, and we found that we benefited more when we injected intelligence into that. So using that as a case study, I want to bring out some key takeaways from that. So observability, adding observability across your entire data pipeline. And that's saying you need to have performance as a central tenet by design and by default. And so when you build data-centric applications, when you invest in analytics, any data use case needs to be built for performance from the outset. And the only way to know that and to tune from the beginning is to have observability all the way back in development environments through testing and into production. You have to be committed to that, shifting left. Monitor and tune all of your apps, all of your assets before they land into your production environments. When you add intelligence in there, informing you, this is how this data is performing, this is how this application is performing that interacts with that data, all the way to if you make these changes that you can have better performance. Whenever you add intelligence, you create leverage so that you've improved that environment, you've improved that experience, and hopefully you've decreased the number of hours, minutes or hours that you need to spend on improving the performance further down the line. So if you do more of that tuning in development and in testing and not wait to production, then you've created leverage because you're doing things proactively. I like to talk about the Hippocratic Oath of monitoring. Of course, in medical, you want to do no harm. That's a Hippocratic Oath. But if you add monitoring to anything, you can actually hurt performance. So you want to make sure that you're monitoring, whatever you're doing in the way of monitoring doesn't cause more harm than it's preventing and helping to diagnose. And so we like to adopt that Hippocratic oath of monitoring and making sure that the monitoring is always for the benefit of the data and for the end user's experience, and not creating more harm, causing more overhead. You also have to add observability for your process. And communication is critical around data and data-centric applications, but it's exhausting. It's really hard. And so you've got to build a data ops process that is really intuitive, standardized, transparent. It's not about bureaucracy and saying, you have these templates for everything and there's only one way to do things. It has to have a degree of agility to it. But it needs to be standardized, and it needs to be approachable and intuitive, and it needs to be understandable and transparent, so that it's not just communication that's happening between two people on a chat channel, but maybe in a more observable place, like an open channel that's not one-to-one. And therefore, people can come in later. Stakeholders can be involved in the process later and understand and get caught up or see what they missed. We standardized around Microsoft Teams. We have heavily leveraged that and use the set up teams and channels within Teams so that we can have ways to track artifacts and then integrate that with Azure DevOps around our whole development process, and all of that is observable for the process. And that's the act of applying tech that promotes that engagement with data ops. Next takeaway is around data testing. And I want to tell you that it's not optional. People do a really good job of testing their apps and their code, but they don't do a good job of actually testing the data. So it's kind of like testing the bucket, but not actually looking at whether the water's clean inside the bucket. And so, spoiler alert, every app is a data-centric app. And so, and the data in the app is the most volatile component in every app. And so, an app can't be fully tested unless you've tried to test it against your wildest data. If you can break it with data, or has the ability to create bad data, then there's a problem. This gets like 10 times worse or 100 times worse, however you want to say it, gets amplified in data science, because we're trying to build models on data. And if the training data that you're using in analytics and data science, ML projects and AI projects is untested, then the overall project is going to be complete garbage. And so data testing is critical. You've got to know that your data is valid and credible. It goes back to what Dan was talking about last, about trust. And you've got to, it's really important to do automated data testing. If you just do it on a one-off, it doesn't work. Data ops is all about automation. And so part of your pipeline needs to be data testing at each stage. Another key takeaway is mapping your data estate. You've got to have a home for everything. You've got to know what is home of record, where it's reliable, know where to take data from, and then where everything lives. You also have to have lineage tracking. Where does data come from? Where does it go to? Does the reliability of it get affected based on where it's coming from and where it's going to? An added complexity of data ops when you add data into a DevOps situation. So DevOps, the responsibility of data ops is larger because there's the compliance piece when you're dealing with data. So you need to know where personally identifiable information, if you heard of PII or haven't before, that's a term that comes up in GDPR compliance, or now we've got different data privacy compliance that's happening in the US. And you need to know where that sensitive data lives in your environment, as well as everywhere that it goes. Just knowing and having it encrypted and locked down in one place is not good enough. You need to know it's also surfaced in 400 reports that may not be encrypted and locked down. And so you need to know that. And then if you're not automating your documentation, it's always going to be wrong. most folks don't even have up-to-date documentation. So having it, but just having it as a snapshot is basically worthless. You know, if you're running and deploying 10 times a day, then it's going to be out of date as soon as you snapshot it. So you need to, just in the same way as you're automating your data testing, you need to be automating your documentation. So you always know where things are. You have an enterprise data dictionary. You understand lineage and data flows. Last key takeaway is that SQL's king. We've seen a newfound popularity around relational database, or at least relational database schemas that is being driven by DevOps and now DataOps, because it's a lot easier to manage the data lifecycle if you are managing schemas that are locked down to some degree. So it's important to be using relational databases or relational schemas wherever possible. Unstructured data is critical, and it's important, but it tends to be better for certain use cases. Parking your data, and then if you're changing your schema, doing schema later, and constantly changing it, it can break your CI and CD pipeline. So when you're adding that observability, when you're tuning for performance, then a relational database is better for that. So, Douglas, what's in it for me? How does intelligent data ops help me? Well, if you're looking at your data as an asset, then consider that, is it a valuable asset that's usable, or is it shattered all over the floor like this vase? Well, if you increase performance, then you remove distraction. People can interact with the data and have a good experience with it. And if you make your data trustworthy, then it will be used much better. So I encourage you to think about your data from a product manager standpoint. Who are the consumers and customers for your data? What are their problems? What are they trying to solve? What do they need access to? What do they need to have high performance for, as well as to trust, and so that you can make sure that you're solving their problems. Make your apps and platforms smarter. That's all about injecting intelligence. And then that way you can be on the road to monetizing your data and making sure that it aligns well with your business. There's a lot of push around data-driven cultures. And having a data-driven culture means good access to high-performance, reliable data, and that demands DevOps or data ops. And if data is going to be your primary currency, then you need to focus on that. Can your users get access to that? Is it trustworthy? Is it fast? Every part of your organization becomes a stakeholder in data ops. So you need to overlay business processes and technology with your culture, and then that recognizes the value of data throughout your data lifecycle. So how are your data teams and your dev teams getting along? Is there harmony between data ops and DevOps? Well, hopefully if you've embraced data ops, then there is. Are you able to deploy 10 times a day or at whatever frequency your DevOps teams? Make sure that your data team and your data assets are not being dragged along. So if you're adding observability and monitoring to your entire data pipeline, it helps a lot with that. Automating your data testing so that that's happening every time, it's not holding up the process. Automating your documentation so that that's happening, it's not holding up the process. With that, you have the ability to really rein in your chaos that sometimes will happen. Last item is around a real hot button, which is around cloud database migration. That may be happening at the same time, and I want to tell you that it doesn't, it's not on a collision course with data ops. You don't need to say, well, gosh, we're too busy with data ops rollout right now, then we can't do that database migration. It actually, data ops helps mitigate a lot of risks and helps you migrate to the cloud if that's an initiative for you. So if you look at a bunch of risks that we regularly run into with our customers, is that they don't have a mapped data estate. They don't understand their data lineage. They have, you know, low visibility of their overall data estate. They need to understand their dependencies, where things are, what the impact is of moving a given database, making changes. If they don't have monitoring, then they have poor performing workloads, and so that means that they take that workload and put it in the cloud. It becomes an expensive workload. And so you need to be able to have that monitoring, be able to monitor it, the workload on premises as well as in the cloud, do a baseline, do comparisons. Also, if you're not testing your data, then your data is untrusted, and it could really discredit, be a distracting discreditation to your overall cloud process. If you have any dysfunction in that three-legged stool, the people, the processes, and the technology, then you're really at a disadvantage when it comes to your cloud migration initiative. So what did we cover? So we talked about DataOps, it being an ecosystem. Like Dan said, it's not something you buy, it's something you do. It's the people, the processes, and the technology surrounding your data and data assets. I talked a lot about intelligent DataOps, which is adding analytics into your DataOps, and then applying that around actualizing your data value, your data-driven culture, having good peace and interactivity between your data and dev teams, and then being able to leverage that for cloud database migration. And the key takeaways from SentryOne are adding observability to the data, to your processes with monitoring, doing automated data testing, doing automated documentation and data lineage, and using relational databases and schemas wherever possible because they're easier to manage in your data pipeline. That's what I had to cover today. Thanks so much.
Thank you very much, Doug. At this point in time, I'd like to introduce our final speaker today, Chris Bergh, CEO and head chef of DataKitchen.
Hey, welcome everybody. This is Chris from DataKitchen, and I want to skip a couple slides here and start off in a different way. So my company and I, we founded DataKitchen about 6 years ago, trying to promote the idea of data ops. And we didn't call it data ops at first. We called it agile analytic operations or DevOps for data science. And the question comes, why did we form a company? And I think it actually comes from my co-founders and I's sense of sort of data PTSD. We were software engineers and managers for years, and then we joined a company in about 2005 that produced analytics in healthcare for thousands of users, did data work, did data science work, did data engineering work. And, our life sort of sucked because our data providers always would give us crappy data. Our data customers were always demanding the next insight. And the people who we managed were always, they all had their favorite tool. Some people liked SQL, some people liked Python, et cetera. And so sort of over the years and sort of running through this PTSD kind of came to the conclusion that what you do is much less important than how you do it. And so let me talk about that. Why does that sort of philosophical statement make any sense to talk about? Well, let's frame it in two ways. So the first thing is, whether you think Elon Musk is a hero or a crazy man, he has had a major impact on the world. And one of the things he talked about in building Tesla was not about the car, but about the factory, not about the machine, but the machine that makes the machine. And there's another case. When I started doing data and analytics in 2005, we had a lot of problems in my first 6 months or a year. And one of the things I love to do is to find someone to blame. And it's not always the case, actually. And actually, if you read Deming, who does industrial manufacturing, assembly lines, he says that 94% of the problems aren't caused by an individual. They're caused by a process. They're a common cause, not a specific cause. And so that leads me to think that, what you do in data and analytics, the model, the algorithm, the data pipeline, the visualization, the governance, even the data itself is just much less important than the processes you use to develop or deploy or monitor or iterate or collaborate on those things. And so what you do is much less important than how you do it in data and analytics. And this is a very contrarian perspective about people and process and operations. just dominates tools, technology, and data. And I'm an engineer. I mean, I love a good tool. And, I've certainly been in the data industry for a while. So it's a very different perspective on things. And so let me drill into that. And that's kind of what I'm going to talk about. So what sort of processes and things are we going to talk about? Well, first process is trying to decrease the time at which you can deploy into production, mainly so your teams can learn more. And instead of spending 3 months doing something, they can spend 3 days and get more feedback. And the second is really about lowering error rates. And this is not just because your data providers gave you crappy data or your poor data quality, but maybe something happened in the processing. And then collaboration, because there's a whole aspect in data and analytics between centralization and freedom, between your dev team and your ops team, and how that works. And then finally, measuring your process. And we're pretty analytic about how we help our customers, but we're not very analytic as an industry on how we work together as a team. And so if I look at it, and I think overall, I'm a bit worried about the data and analytics industry, because not only are people suffering, but we've had this big boom in AI and ML, and a lot of people aren't spending time on things that are visible by their customers. They're spending a lot of time working on errors and operational tasks because of this complex roles and orgs and tools and data that go on in collaboration. And as a result, most companies are spending, and we've done surveys with Eckerson, they're spending weeks or months to take some 10 lines of SQL, a predictive model, and get it from dev into prod, or they're having high errors when they deploy or high errors in production. And as a result, sort of analytic teams are kind of suffering a bit, and that sort of PTSD that I experienced, I think a lot of teams are experiencing. And so, I think if we look at data ops as a definition, and we've, I think, been leading the industry in defining data ops. We wrote the Wikipedia article, the manifesto, we wrote a book. And, in short, we're saying you don't have to choose. You can go fast with new features, and you can have high quality and low error rates, and you can collaborate with your team. It's not one or the other. And so that's a really contrarian perspective. Don't focus on your tools, focus on your process, and you can have your cake and eat it too with that process. So, maybe you don't believe it, maybe you do, but that's part of what the idea is. And I also think that sort of resolution of conflicts that happened in DevOps, that you can go fast and have a high quality is evidence. And if you read some of the latest DevOps research, like from Nicole Ferguson in the Accelerate book. So let me go into this a bit. So here's another aphorism. It's not about data silos. It's about people and tool silos. So what does that mean? Well, let me talk about 3 pipelines that you have to do data ops. And the first pipeline is the production pipeline. And this is thinking about what you do as a Toyota manufacturing factory. And so data goes in one side, and value, charts, graphs, models, visualizations, other systems goes out where your customers interact with it. And in between, there's a manufacturing process. And that could be batch, that could be streaming, and think of workstations on that manufacturing line. And there's tools that people access the data, databases, there's transformation tools, there's data science tools, data visualization tools, data governance tools. And, my co-hosts have got great versions of that. Like, Qlik is a really good data visualization tool. They have ETL tools, but it's fundamentally a manufacturing process. And you want to run it where the things you put out have low errors, because errors are so problematic. And there's 50 plus tools in each category. And, people love tools. Like, I'm not more of a code guy than a visualization guy, but in my experience, I just never want to sit through discussions of whether Tableau versus Cognos are right, or Python versus R, or whether you should use a visual UI or use SQL. I mean, people have their choices and companies have their choices. But at the end of the day, you're running a manufacturing line, and that dominates what you need to think about. And then the second is those manufacturing lines aren't really owned by one person. Conway's Law, which states that the technical things that we create are sort of built in a way that reflects our organizational structure, is really true, because most companies don't have one data analytics organization. They have several or dozens. They have maybe a centralized data warehouse team, maybe off somewhere they have a data science team. Maybe they've got a bunch of line of business people using self-service analytic tools or self-service data prep tools. And so at the end of the day, your customer sees this combination of the work the IT and the data science and the line of business teams do. And, that's, if there's a problem, well, who fixes it? Where does it or does it work? And so this organizational structure applied to these pipelines, I think, is actually a really salient part of what we're trying to address in DataOps. And then the other pipeline, the second pipeline, in addition to the production pipeline, is how to think about how you get your work, whether it's SQL or a Tableau workbook or a model, from the fingertips of your person on your team into production. And so there's a process that does it. It's a continuous deployment or integration process. That's a lot like software. And in fact, the DataOps perspective is that analytics is code, whether that code happens to be in a Tableau workbook or in an R model. And so getting that into production, I think, is important, and automating the process to do it. But you've got to do these things, again, that seem really impossible. You want to run a really high-quality factory, low errors, but then your customers are going to ask you to change it. And so it does seem, that you want to pull your hair out. Those things are impossible. But I think there is a way that you can do both at the same time, and as well as have collaboration and measurement. And so the final pipeline that I think you need to think about in DataOps is not only the value pipeline, which is sort of orchestrating all the tools in production, or deployment pipeline, which is orchestrating the process to get code from a dev box into production, but the environment pipeline. How are you going to build a development environment or a QA environment that's reflective to production? And sometimes a lot of analytic workload doesn't happen in one place. Some of it happens on-prem, some of it happens in cloud. There's multi-cloud. And so the environments at which your analytics run are actually incredibly important. And so as I keep going here, the next thing is I'd like to talk about how customers approach doing DataOps. And so what we say and help our customers is really to focus on the business problems that DataOps can address. And that is really slow deployment, too many errors, lack of coordination and measurement. And we're kind of a believer in this idea of theory of constraints, that you should find a bottleneck, find slow deployment, find too many errors, find lack of coordination, and pick one and work on it, remove the bottleneck, increase the flow of innovation, and then try again. And that's sort of a theory of constraints. And let me give you just two quick examples of where a customer did that. So one customer was a European telecom, and they had slow deployment. So they had a lot of tools, but they had fundamentally an Oracle database that took months to actually take it from the dev version of the Oracle database and get it into production. And they had an ETL tool, some scripts, some SQL code, but they really it took them forever to get things, and their customers were complaining because of it. And so what are the keys to removing this bottleneck? Well, the first key is to think about automation. How do you actually move stuff physically from one system to another? How can you automate the deployment? And then second, in order to make sure the deployment works, you've got to abstract the environment that it's in, so that when you move things, there's a commonality between your dev and QA and pre-prod and production environments. And then second, you have to prove that what you do works. And so testing, in this case, having tests embedded in part of our software called a recipe, that runs across it, and being able to, in each environment, run a full set of regression. It's not just unit tests, it's functional tests, system tests, and be able to make sure that the whole system is running so that you know it works. And when you change one part in the middle of this complicated graph, that you know the downstream stuff works. So that's one way people approach it. Another way is to think about other people come at DataOps in a different way. They say, my production, users they don't trust the data. I'm getting Slack. Every time I come into work, I get 5 Slack messages that something broke, and my life is sort of crap. And so how do you reduce errors in production? Well, this customer is a transportation customer, and they had just a lot of systems. They had NiFi and Kafka for streaming. They had Fast Batch. They had Batch with Informatica. It went to Oracle in the cloud. They had data science and Tableau, and it's just a really complex error-prone production environment, and so their customers were complaining. So furthermore, the actual organizational structure of this was complicated because they had different teams responsible for different parts. So how do you solve that? Well, what we did is sort of lay one of our recipes on top, and I like the term that was used before, observability, but you could also call it tests and monitors. You need to actually tell, not only are your servers running, which is fine, or that the processes that ran your NiFi process or Informatica process. We actually have to dig into the data itself to see if it's right. Do you have the right number of rows and columns? Do the row counts match as it moves from system to system? Are there tests that match the heuristics of the business? And by doing that, you can find out if something's wrong much before your customers do. And then you can go in and say, whoa, something's wrong. Send an alert, Slack message, Jira ticket. And you can find problems before your customers do it. And I think that's a really key thing. And my own PTSD wakes up every time. And I've had 2 conversations just this morning with customers who are running production systems with no automated tests. And it just freaks me out when that happens, because I remember all those mornings I would get emails or calls and people would say the data broke because, well, someone put in bad data in the system. I don't own that person. They don't report to me, but yet I've got bad data and I'm dealing with the result. And so if you can test that, really test it and alert before it happens, then you can end up working with your data suppliers to make sure it's right. And so just the couple last things. So, we think that the purpose of data ops is really to help you get more time to do new stuff, new features, and reduce the amount of crufty error stuff that you have to do. And then second is to actually help you, increase the deployment speed from months to hours, reduce the amount of errors. And actually, I think it really does improve the productivity. And so how do you go about doing data ops? Well, while we're here, we have a software product. And so we have that's great. It helps on cycle time and error rates and collaboration and measurement. But, you don't have to buy it. Well, my VP of sales will kill me, but I really think you should start with data ops today and just don't buy any software. First of all, if you don't have any automated tests, create some, right? And that can help decrease the time at which you can deploy. Second is if you're having errors in production, take an Excel spreadsheet and write every error in the spreadsheet. Then get a quality circle of your engineers and operations people to look at them. And then once a month, find a pattern in them and fix that errors. Just focus on lowering error rates in production. Collaboration, well, all this code is, all your work is code, so put it in Git. Git's free. And then finally, measure your process. You can count these things, how many tests you have, how fast you can deploy, how many errors. And you can put that in a spreadsheet and measure it yourself. So the ideas in data ops can be started just by your, today. And so the last slide I have is just really, if you want to learn more about the ideas in data ops, you can go to the manifesto, read 18 points, and sign up. You can read our cookbook. It's about 200 pages with lots of pictures and learn more about data ops. And if you, think our software can help you accelerate your journey to data ops, well, then hit our website.
Thank you very much, Chris. At this point in time, we're going to dive into questions from our viewers today. Our first question is for Dan. Dan, what is the role of AI and machine learning in data ops? Okay, it looks like maybe either Dan, you're on mute, or maybe you're still having trouble connecting. So why don't we move on to Douglas? Douglas, does data ops help with compliance and data privacy, for example, GDPR, CCPA?
Sure. Yeah, thanks for flipping that one over to me. I touched on that actually when I was talking about documentation, and so if one of the things I was talking about is having a home for all your data, knowing where it is, understanding your data lineage, and the big thing that tends to create liability is not knowing all the places it also creeps out to when you're talking about sensitive information. And I guess another call out here is that this is actually, part of the expanded complexity of data ops versus DevOps. DevOps is all about, the lifecycle management around the application pieces and the code there. But then when you're actually dealing with the data itself, you've got to deal with different stakeholders that use the data different ways, coexistence of data ops and with the DBAs along with data science and analytics users, and then the compliance piece gets added in on top of that is how are you locking things down. And so if you don't know where everything is and what it needs to be done, then it gets a little tough.
Got it. Thanks, Douglas. Chris, our next question is for you. Can you buy data ops?
Yeah, you can buy our software. and that'll get you to data ops faster. And so one of the challenges I think happens in any tech industry is the term gets popular and then people label pre-existing things with the term data ops. And so that happened in software with DevOps, it happened with big data. And so I think, one of the things is for everyone to figure out exactly what the definition of data ops is. And so, there's a lot of different reading out there. And I think that's the first thing. People have to understand what data ops is and what the principles are that govern data ops. And then, try to approach it first. I think start simple. The suggestions I made are a great way to get started.
Understood. Thanks, Chris. Okay, Doug, our next question is for you. Where do DBAs fit into data ops?
Sure. I guess I talked a little bit about that just a moment ago, but DBAs in a data-driven culture, DBAs are just one of the stakeholders for data, but then they're also own the administration capability too. And so I guess the point of debate and you may have found yourself in these type of conversations, is the DBA still a role, or is there more expansive data ops role in organizations? And so I think that there is a bit of blurring of the lines of what DBAs are responsible for. And if you adopt the shift left mentality and add observability into your whole data pipeline, then your DBAs should be involved with the overall process and much more integrally involved in the development and the testing processes than perhaps the traditional DBA role. And I guess my summary statement is that I would encourage people to break down barriers in what certain roles do and don't do, and have more stakeholders involved in the holistic process of your data pipeline.
Understood. Okay, we're going to try Dan again. Dan, what is the role of AI and machine learning in data ops?
Hey, Stephen. I'm hoping you can hear me now because this is a good question.
Yes, we can hear you now.
Excellent. So certainly the output of data ops plays right into AI and ML. It's one of the big use cases. But AI and ML also gets used in part of this intelligent pipeline. It starts from preparing the data. It may be using things like a recommendation engine when I'm trying to join disparate data, how best to bring that in, how best to map it and format it. So that leverages AI and ML. When you go to take a data set and put it into a catalog and make it available to a business user, using AI and ML to tag and automatically mask the data for things like PII. So I want to, depending on the user's level, I may want to make things like social security numbers available, or I may want to mask those in an automated fashion. And finally, on the consumption side, if I've got a data set and I want to generate insights, this is an area where Qlik is very strong on the analytics side, using augmented intelligence. So bring a data set in and automatically find the interesting patterns and outliers. And let me start as a business consumer with some insights that the tool has been able to glean automatically. So that's just a couple of examples, but more and more AI and ML is going to be an integral part of everything we do throughout the entire supply chain, from the original source to how it gets transformed to how it gets consumed.
Got it. Thanks, Dan. Okay, Chris, our next question is for you. A lot of companies are using the term data ops, but their offerings are very different. Can you help clear up my confusion?
Yeah, I think there's an awful lot of ops terms out there too. There's data ops and DevOps and ML ops and model ops. And actually, we just wrote a long blog article. And I think it goes back to the idea that we're all working on a shared complicated system, and there's a set of principles that you apply to manage and run with that involve focusing less on the actual things that you do and more on the cycle time at which you can deploy, the error rates in production and collaboration. And so to me, the differentiator is that those are the things you need to focus on if you're doing data ops. And so it's not about a new tool for your individual contributor. It's about getting a system in which all your individual contributors can be successful. And so I think it's clear about where the market's going with that.
Got it. Thanks, Chris. Doug, we have a question for you, and it is also kind of about definitions. What is the difference between data ops, DevOps, and data DevOps?
Sure. Yeah, and I'll circle back to some of what I was saying in an earlier answer, but where DevOps is focused largely around the change management and the pipeline for your code and your apps. Of course, the same applies to data for data ops. There's a lot of overlap in, people can split hairs about the difference between data ops and data DevOps. I think of them as the same. It's just that we kind of bridged from recognizing the data assets in the DevOps environment and adding the data stakeholders to DevOps, and we called it data DevOps. And then moving that forward, we said, wait a second, it's a little bit bigger than just the data assets that are getting dragged along in moving a data-centric application through the pipeline, but instead we also have to reconcile different stakeholders for the same data back to the app users and people that are getting reports, and then folks that are using the data science team that are using the same data for data science projects. And so you have different contention of use cases around that, and data ops is all around building a structure, people, processes, and technology so that they can peacefully coexist. And then you add in that compliance piece that I mentioned a few times, and saying, wait, we still have to secure this data. It still has to meet certain compliance. Certain people can't see that. This still has to be encrypted, and that affects how you can interact with it with different tools and where it can be stored. And so all of that complexity is part of what we solve for, and have to have, again, people, processes, and technology to make sure that we don't hurt the performance of the data or the performance of our processes to take data to market, whether it's internally or externally.
Got it. Dan, circling back to you, are there other use cases beyond analytics where data ops can be applied?
Yeah, absolutely. We talk a lot about analytics because I think it's probably the most prevalent use case for data ops. But other use cases, we see things like application, legacy app modernization and extension. I'll give you an example. One of our customers is Vanguard, and Vanguard gave a great main stage presentation at this year's Amazon reInvent. And what they're doing with our technology is they're using data ops to move data in real time from their core mainframe transactional system at great volume. They process things like over 60 million row updates per hour needs to be moved to the cloud and moved within a 1 to 2 second latency window, so they can build a whole host of new web and mobile applications and keep all of their core processing on the mainframe on-prem. And they need to move this data not only in great volume with low latency, but to move it into things like Kinesis and DynamoDB and S3 and RDS. So, having this really agile, really performant, really fast way to move the data into the cloud so you can build these next generation applications, that's a great use case for data ops. And it really pushes the envelope in terms of being able to do things at scale and in real time.
Understood. Chris, our next question is for you. What are the common data ops tools you recommend for, 1, refreshing the latest data, and 2, change monitoring of databases?
I think change data capture and ETL tools, there's so many of them out there. I think that my 2 co-hosts have 2 good ones. And so, from to me, I guess I don't look at data ops as have anything to do with the tools that act on your data. There's a huge market of ETL and change data capture and data governance and biz and science tools out there. And so pick the best one that works with your team and standardize one. I think it's about the process that those tools work in and that the people work in that matter. And so, that's my sort of contrarian perspective is having been in the industry for a while, I used a lot of tools, being a very technical person, that it's just not about the tools. It's about the factory that those tools operate in. And I think that's where data ops speaks. And I think there is, just like in software, there's some tools to help, deploy and orchestrate and monitor that factory itself that we need to focus on, as opposed to let's just get another, next-gen ETL tool.
Understood. We're currently at the top of the hour, so at this point in time, I'd like to give each of you the opportunity to just address some final remarks, what you would like our attendees today to walk away really keeping in mind, most important thing, with respect to unlocking the power of data ops. And why don't we start with you, Chris?
I think the most important thing is that, you don't have to, have PTSD. That there is a way that you can go fast and not break things and work with the complexity of teams and tools that you already have. And I think that vision that there is a way that you can reclaim the initiative and not be sort of beaten down with all the troubles that happen in analytics, that's the thing that we're trying to promote with data ops.
Understood. And Douglas, your final thoughts?
Sure. Just a reminder that the interdependency between the people, the processes, and the technology to support your data assets, and the pervasive use of database performance monitoring and how you can use that across your data pipeline to add observability and the value it can create.
Understood. Thanks, Douglas. And Dan, your final remarks for today.
So I would say that, most people, when you talk about what data ops is, they nod their head and say, oh yeah, this is either something I've been aspiring to do or something that we do. And that's good. So its value proposition is well understood. How you get there, it's not a rip and replace. Again, it's people, process, and technology. Think about the technologies that you have or technologies that you can augment to help get you there faster, but think also about how you're organized and the process to get there. And the more that you can automate and do things in real time, the greater the business impact will be.
Understood. I'd like to thank our speakers today, Dan Potter, VP of Product Marketing at Qlik, Douglas McDowell, Chief Strategy Officer at SentryOne, and Chris Bergh, CEO and Head Chef of DataKitchen. If you would like to review this presentation or send it to a colleague, please use the same URL that you used for today's live event. It will be archived and you'll receive an email once the archive is posted. And just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on May 29th. We will reach out to you via email if you are the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.
Thank you, ladies and gentlemen. This concludes today's webcast. We appreciate your participation. You may now disconnect. Presenters, please stand by.